Hello and welcome to the second session of my lecture about moment resistance of laterally supported members and the topic of bending members. Moment resistance of a laterally supported member. The laterally supported member, as you can see in the picture, are the members that their compression flange are somehow supported with something. As you saw in the previous session, it might be the compressive flanges in concrete or or beam or something like that is supporting that compression flange, and that will consider as a laterally supported member. How do we calculate resistance moment for class 1 and 2 of the section for the members with laterally supported? Okay, clause 13.5a is a clause in S16 that you can find, and this clause talks about the bending moment capacity of the members which are laterally supported. Okay, MR is equal to phi MP, which is phi Z Fy. As you can see, I told you in class 1 and 2 we can use the plastic moment capacity of the member, and phi can be found from clause 13.1, which here is 0.9, and Z is equal to integration of y over dA, which is equal to summation of a y bar. For class 3 sections, as you can find in class 13.5b of S16, the resistance moment is equal to phi my. As I told you before, in class 3 you cannot go beyond my, so my is the pick, and it is equal to phi s dot Fy, and as you can remember, s is equal to I over y, and it is class 13.1. For class 4 sections, which is on clause 13.5c, if the flange is class 4, web is class 4, resistant moment is described in CSAS 136, which is the North American specification for design of the cold form steel structure members. If the flange was in class 3 and web was in class 4, resistance moment requirements of class for calculating the resistance moment, requirements of clause 14 shall be applied. And when the web meets the requirement of class 3 and flange is class 4, so it's exactly the opposite of previous one, resistant moment shall be calculated as follows. Resistant moment is equal to phi SE Fy. What is SE? We're actually doing something like this. We are modifying, if this is B, which is width of the flange, BE is something like this. So we are modifying the width of the flange with these three limits. First one is for flange supported along two edges parallel to the direction of stress. The second one, for flange supported along one edge parallel to the direction of stress. And third one, for flange supported along only one edge. Thank you for listening to second session of my lecture. Please either comment or email if you have any questions.